The next episodes of Thriving Construction come straight from Future Build. Huge thanks to Eco Cocoon. The space was great for chats, acoustics, and even better well-being.
So quite often when people hear geothermal, they think Iceland, they think volcanoes, they think super high temperatures, which is useful. You can generate electricity from that, but it's not something that in the UK is particularly relevant. We've got the one project in Cornwall and so on, but isn't applicable to the majority of the UK. You come a little bit shallower and go to sort of 2-3 kilometers deep, and that's where your temperatures might be sort of 80 degrees, 90 degrees C. But again, that's quite specific in terms of the geology that you're on. If you go shallow and you go to sort of 200, 300 meters deep, and I was looking up the other day, the height of the shard is about 300 meters high, sorry. So we're talking about the same height, but going underground.
Yeah.
And at that kind of depth, your temperature's around 15 degrees C, whatever the weather. And so this is where then if you put a heat pump on top of that, your energy efficiency, you can reduce the consumption by a factor of 4, your energy needs. So this is why going underground is really useful. But then to answer to your question spatially, this is where, yes, your classic solution, your garden solution would be the slinky. Then you do need a very, very large garden. You can go vertical, and they tend to be spaced out at 10 meters or so. Again, you need quite a lot of land space for that. And in the urban environment, we don't necessarily have, bukus of space available, or it's being used for something, right, in an urban environment. What we do is we can bring an inclined drilling technique, and this has come across from oil and gas, and we drill out at an incline, which allows us to take a very small surface footprint and go out underneath the building, out under a park, under a car park, whatever it happens to be, and access the ground underneath. And this is where the UK, if you like, is sitting on a giant thermal battery. But what we've got to try and do is access it. And this is what one of the things that we're trying to do. Because we want effectively the higher efficiency of the ground source of shallow geothermal to play its role in the UK's energy decarbonisation.
And so how do you see then the technology you have being rolled out and being more common than what it is at the moment? And the reason I'm saying that is because it seems as though air source feels more accessible and feels more common than what it is. But the issue with the air is the temperature in the air has got huge fluctuations, and you can't predict it either. But the temperature in the ground doesn't have such a variance.
Yes. And I think the first important thing to say is as we go through the energy transition, it's not always one technology against another. Right. Some technologies will be more applicable than others. And if you are in an individual house, you only have a certain amount of money to spend, you're probably going to go down the air source route. And that's okay. But when you get to larger systems, you probably start to talk about multi-energy sources. And this is where ground source needs to play a role, because then the higher efficiency really plays in if you're in sort of your very large kilowatt or megawatt type systems. So I think that's probably the first point, right? Because then what you can do is rely on the ground source for the bulk of the heat demand, particularly like you said with those steady temperatures that we see from the ground, and we're not as reliant on the air temperature. The other, I think, really important thing that we don't necessarily talk enough about is that energy consumption reduction that you're seeing not only reduces your energy, but it reduces your exposure to volatility in energy prices, which I think we're all, becoming increasingly exposed to at the moment, right?
So it sounds like from what you're saying then that the real benefit here is around the community heating types of scenarios as opposed to individual dwellings?
So we focus on large-scale systems. So that could be domestic, it could be industrial, it could be hospitals, it could be schools. It's more a scale question. So yes, on the individual home perspective, we don't really tend to work in that space. It's the large-scale systems, which can be blocks of flats, it can be groups of houses. It could be moving into the heat network space where you connect the school and the hospital and the shops and the houses all together, because then it's the efficiency of scale that you're starting to look at, which then allows you to use ground source, allows you to use multiple energy sources in order to basically optimize energy consumption, optimize the carbon footprint, and also optimize the cost of of heating and cooling delivered.
What are some of the biggest misconceptions then, apart from the ones that I've mentioned, that show up for you and for the organization or the industry on a regular basis?
Not sure it's a misconception, more an unawareness maybe.
Yeah.
Sometimes I describe geothermal as the invisible energy source because it's not something that people talk about. Your head, as I mentioned, goes straight to that volcano if you say geothermal. They don't know that it's available to 90% of the UK. They don't know that it's under your heat. It's local, it's renewable, and it's here, right? And I think perhaps it's that invisibility almost that's the problem. And then that plays into whoever's advising and designing systems. It plays into discussions in government on policy. It plays into discussions with investors on stepping into the energy infrastructure space. So it is something I think we need to raise the awareness on the benefits, fundamentally around energy efficiency and long-term energy efficiency that I think we need to elevate.
And what types of conversations or what projects can you talk about where you've seen actually, because they've used this technology, it's completely transformed not just the efficiency, but also the what's the word I'm looking for? The desirability from an investor's point of view into a project. Do you get involved in anything of that size or of that scale?
So some of the things that we've seen, maybe more on the investor space,
Yeah.
is when investors step into a new technology type arena, they're very risk averse. So being able to do a design of a system, we have digital twins that we apply for both the equipment on surface, but also the ground below, allows us then to step into the performance space. You can see we have digital monitoring, we have algorithms that start to learn how the system is behaving. You can optimize further, and raising the visibility of how the system is performing is then really important because it de-risks effectively then the project, right? And if you can step into that space over a long period of time, which again is what investors are looking to do, then it helps with the economics because all of a sudden you don't have ridiculous percentage rates that you're trying to match. You can bring down the return in time on the investment. And that sort of opens up the conversation then as far as people willing to invest in the space. And I think that's particularly important because, yes, there are grants available. The government has grants in certain sectors like PSDS and social housing and so on, but not everybody that applies for a grant receives one. They may have to have multiple goes at it, which means we need to open up private investment into the energy infrastructure, which means, again, you're starting to talk at scale, large system at risk.
Thanks for watching to the end. I think that you'll like this, but before you do that, just make sure that you've commented and liked below, and also that you subscribed.